So looking at this do now problem, we want to go ahead and distribute, or we can use the array method. So if we're looking at the array method, we know this is A, and it's B plus C plus 1. So we have the area of this would be AB, plus the area of this would be AC, plus the area of this would be A times 1 would just be A. So we'd have AB plus AC is A. Same thing, if we do the distribution, we get the same result. AB plus AC plus A, which is answer choice B. Coming over here, write the expression in standard form. We see this is a division, which we need to change to a multiplication. So we're going to multiply by the reciprocal, which would be 2 over 1. So it's 14g plus 22h times 2 over 1, which is really just 2. We're going to distribute that in. Multiplying by 2 is going to give me 28g plus 44h. Answer choice C. Alright, let's look at our aim for today. Alright, today's aim Kipsters will be able to use area models in distribution to simplify expressions or factor expressions. So looking over here, we have this first box. On the left hand side we have factored expressions. On the right hand side we're going to be looking for distributed or simplified expressions. You should be able to complete this box on your own, so please go ahead and do that. It should take you about 1.5 minutes. Alright, so looking at the first half, we're just doing the distribution, so we can see 2 times x and 2 times 5, that's 2x plus 10, 3 times x and 3 times 4, which is 3x plus 12, and so on. As we come down and look at these, we're looking at factoring, so we're taking out the common factors between this. So this is 5 times x, and this is 5 times 6, so our common factor is 5 that I can take out. This is 8 times x, and this is 8 times 1, so we can take out a common factor of 1. This one is 3 times x, and 3 times, negative 3 times 4. So again, this is one where we have to be really careful, is looking at this, we need to make sure that whatever this multiplication is on this second distribution is a negative, so we get that negative 12. So our common factor here is 3. And looking at this one is 5 times 3 and times x and 5 times 4. So our common factor is 5. We can factor out that 5. Alright, we're going to do the same thing down here. Rewrite each expression as the product of two factors. These are going to be a little bit more complicated than the ones that we saw above, because we need to find greatest common factors. So looking at this one is going to be 9 times 8 times t plus 8 times 1. So my common factor is 8. A lot of people tend to, when they factor out something like this, they tend to make it disappear, and they'll try and tell me that this is just 8 times 9t. But if we reverse the process here, we're definitely going to recognize that this is not going to be 8 times 9t, because that would just be the 72t. That's why we also need the plus 1 here for our remaining factor of 1. Go ahead and try out with your partner the other 5 problems. Alright, check your answers really quickly. The one I really do want to focus in on, though, is this one here in the middle. So you'll notice that when I went through this problem, I first identified 6 as the common factor, and I got 6z plus 12. I knew there was still a common factor between 6 and 12, so I factored it one more time. When I factor it out, that means I'm just going to factor it out, and that whatever I factor out is going to be joining the multiplication here. So I noticed there was another factor of 6 I could take out. And so that became the 6 times 6 on the outside, making me realize that originally I could have factored out 36 times z, and 36 times 2 would have been my original factor. So definitely focus in on there when you get done factoring the first time. Check, are you really completely factored? The other one that I think is kind of important to note down here is this one, making sure that we notice that we have a minus 15, so when we do this distribution for the second one, that needs to result in a negative number. Alright, here we've got an area model that's all put together, and so what we need to do here is we have the variables x and y stand for positive integers. So we've got an area model where we can add these things together, and it represents the area of the array below. So we want to determine the length and width of each of the rectangles. So we know that really what we're looking at here is this value on the outside times whatever these common factors are in the middle are going to be these pieces up here. So we're looking for the common factor, which I already gave away here, is 2. And so then what happens when we factor that out? Well, when I factor this out, that's going to leave me with x. When I factor this out, that's going to leave me with 2 times 6y. And so this is x, this is 6y, and 8 would be 4 times 2, so when I leave that, that's going to be 4. So that helps me factor that piece out. So we can see that we can use the area models also to help us factor if we need that visual representation. So for this one, it just wants you to go ahead and write the product of the expression of the rectangular array. So just write the expressions in 2 different forms here. So we're going to look for the distributed form and the factored form. Go ahead and write those down on your own. Should take you about 25 seconds. Alright, so our factored form is the form that's already given here. But one thing I do notice about this, is that we can write it as the other form, which is the distributed form already given to us, 24d plus 8e plus 6. Alright, factor the expression by finding the greatest common factor of the terms. Again, if you want to help you out, you can draw the array here. This is 48j plus 60k plus 24. Now I need to find the greatest common factor. So I'm looking through here and I'm just thinking about my common factors. And I can see 4 kind of immediately jumps out at me, but I also want to try some things that are bigger. 8 might be a possibility, but 8 doesn't go into 16. And then finally I get down to 12. And I see it looks like 12 will go into this one. This one's going to give me 12 times 4j. So this is going to be 4j. And 12 times 60 is going to be 12 times 5k. And this is 12 times 2. It's going to be 2. So in my factored form, this is going to be 12 times 4j plus 5k plus 2. So I think the most common mistake here is to be not pulling out the greatest common factor and to only get to a factor of 2 or a factor of 4 or a factor of 6 are both things where I think people often run into trouble here. Alright, let's flip on over to the other side. Alright, in this exercise you're going to be working with your partner or yourself in this particular case to write each of these in a factored form. So all of these can be written as a factored form as the product of sums. They may just take a little rearranging. So I'm going to go ahead and walk through the first row with you and then have you do the second row on your own. So this first one, this one's pretty obvious to us. We can see that we have the common factor out here. So this is going to be 3 times 2 plus 5. Over here we see the 1, 2, 3 groups of the exact same thing. So that goes back to kind of, we've been talking about this for almost 2 weeks now. 3 groups of 2 plus 5. And this last one is the one that gets a little bit tricky. So we definitely need to do some rearranging here in order to sort this one out. So the first thing I'm going to do is I see the 5 plus 2. I'm just going to move it off to the side. And here I'm going to go 2 times 2 plus 5 times 2, and I see that common factor in this piece down here. So I'm going to focus just on this piece. And this is where it's kind of hard to see, and that's why we really need to focus in on just individual pieces here. I can factor out of this individual piece a 2. So I'm going to rewrite this one as 5 plus 2 plus factoring out a 2 of that part. And this is 2 times 2, or 2 plus 5, or 5 plus 2. So I've got 1 5 plus 2 plus 2 5 plus 2's. That's going to give me 3 5 plus 2's. Alright, so when we're looking at a problem like that, I do need you to see and be able to manipulate that. So we need to use the commutative property. You should be showing me how you use the commutative property and factoring to get you there. Go ahead and try the next 6 on your own. So you've probably finished the first 2. These are pretty obvious here when we get these. The other 2 are less obvious. The one thing that I want to say before we go over them is to make sure that if you've done these problems, you haven't just given me an answer because you've recognized a pattern, but you've also given me the work and the steps in between. That's the really important piece of this, is really being able to justify and show your response. So if you just have an answer, that means I don't have much of an idea what your concept is. So I'm going to give you another minute or 2 just to go ahead and make sure that you finish it. Pause the video if you need to. So looking at this, I'm going to rearrange these pieces. 5 plus x is one group, and here I want to change this 5 times 2 and plus 2 times x. That way I have the 2's that I can factor out. So in this particular portion of the expression, I have 2 times 5 plus x plus a 5 plus x is going to give me 3 5 plus x's. We can do the similar thing down here. My y plus x plus 2y plus 2x. This portion I can factor out the 2, so it's y plus x plus 2 times y plus x. So that gives me 3y plus x's. Alright, moving on down to this problem. This is kind of the important piece. I think this is where a lot of us have been struggling on our tests, is thinking about problems like this and how we can represent problems like this using mathematics. So we're going to write this expression in 2 different ways, and we're going to make sure that we're able to describe how we can. So it says a new miniature golf arcade opened up in town. For convenient ordering, a play package is available to purchase. It includes 2 rounds of golf and 20 arcade tokens plus $3 off the regular price. There is a group of 6 friends purchasing the package. So let G represent the cost of a round of golf, T represent the cost of a token. Write 2 expressions that represent the total amount that the group spent. So the important thing here is to think about there is a group of friends, and that group is 6 friends. So when you write your expression, that's what you're thinking, how many groups you have, and then how much do the arcade tokens cost, how much do the rounds of golf cost, and how much are they saving per person, and then we're going to write those expressions. So go ahead and take 2 minutes to write 2 expressions that are equivalent that represent this situation. So with this, I also think that sometimes it's helpful to think about if we have 6 friends, what is one person paying for. So when I think about this, I start with this, I think about, well, there are 2 rounds of golf, so 2 times, where does it tell me how much a round of golf costs? G, 2G, and then they pay for the 20 arcade tokens, so 20T, but they get $3 off. So this is a little bit confusing. So it says plus, so we'll write that as a plus, but then that's a negative addition here. And then there are 6 of them, so we have 6 groups of this being purchased, and we're going to have this value. So if we wanted to write this in a different way, we could go ahead and distribute, and that's going to give me a simplified answer of 12G plus 120T plus negative 18. Alright, finally, we're going to look at these last couple of problems. This says, what is the opposite of negative 6v plus 1? So we can think about this as, remember, thinking about opposite as we want the negative 6v plus 1. And we know how to deal with this. It says to use the distributive property to write an equivalent statement to part A. So we're looking for the equivalent statement here. We've talked about this as a distribution of negative 1. But we've also talked about just knowing that the opposite of a group is the opposite of every piece of the group. So either way we look at this, we're going to get a positive 6x plus a negative 1. So go ahead and rewrite each step along the way. We're going to rewrite this in standard form. So we're going to start with 5a minus a minus 3b. And we're going to step through this. And we're going to justify each step along the way. So think about what the first thing you need to do is, before we can do any grouping or any commutative property or any of that, we always need to do the same thing if we see subtractions. So that's going to be 5a, change this to add the opposite, and change this to add the opposite. So our justification here is that from this step to this step is that subtraction is the same thing as adding opposites. Alright, then we want to see, we have the opposite of a group, so we have 5a, and then this is going to be negative a, plus the opposite of this is going to be positive 3b. So we've talked about this a couple ways. One, we can refer to this as distributive property as if we distributed a 1 in. So that may be one justification. We've also used the justification that the opposite of a sum is the sum of the opposites. Either way is an appropriate way. So distributive property or opposite of the sum is sum of its opposites. And we don't have to really do any commutative property, or it's really just more of the associative property to combine our like terms here. That's going to give me 4a plus 3b. And so really we kind of use the associative property, but we also definitely combine like terms. Alright, go ahead and work on each of the problems below to distribute and combine like terms and simplify the expressions. Alright, so as we look at these, again we need to do the same thing that we've done before, which is if we have subtractions we need to go ahead and change them to additions, and this is going to be once again something that we're doing over and over again here in 7th grade. So we can use all of our properties. So I'm going to change this to an addition, and I'm going to distribute in this negative 3. That's going to give me negative 6p plus negative 3 times negative 3. This is one where I have to be really careful. Negative times a negative gives me a positive 3 or 9q. Looking down here at this other one, again, thinking about this, change this to add the opposite. Now this becomes the opposite of the group, and here we need the opposite of this, becomes negative b plus negative b. So the opposite of the group tells me I want the opposite of the individual pieces, so the opposite of positive a is going to be a negative a, and the opposite of negative b is going to be a positive b. So you have negative a plus negative a is plus positive b. And remember, when we see this is like negative 1 plus negative 1, so I'm going to get negative 2a plus b. Alright, go ahead and jump on over to your alone time and show me what you know.